Now that we've set up our study graph, we're ready to actually set up the refinery study as our next step. So again, we're going to basically think about the generation method we want to use. And in this case, we're going to optimize. I can sort of set the number of solutions. That's just the population size we're going to use, as well as the number of generations. For the inputs, I don't have to choose all of the different inputs. Often you don't want to, because you're trying to sort of test a few different inputs at a time to kind of figure out really what the behavior is and drive the ultimate result that you want. In my case, I'm just going to look at a couple of them as opposed to all of them. I'll look at the midpoint radius and the top radius of the tower, as well as the rotation at the top. For the outputs, again, you don't have to choose all of them. I could choose to ignore some. I'm going to try minimizing the total cost and maximizing solar insolation, okay, computed with a solar analysis node, but also maybe trying to minimize the surface area per floor area. Pardon me. That will typically sort of be some sort of indicator of like, energy performance. So great. That's how I'm basically going to set up the study. Let's just go through and think about how to do it. So always start with your planning for what you want to do, because just working with the tool is actually pretty easy. Just in Refinery, let me go over here, just let me save in Dynamo the study graph. I'll say let's make a new study. Optimization will be my method, and I can choose what I want to have Refinery change. I'm not going to change the base radius. I'm not going to change the middle rotation. I decided these three inputs are enough for me to kind of play with for this study. I can create additional studies and check some more. For the outputs, let's think about all these outputs and which ones we want to use. So surface area per floor area, that's one I decided I wanted to minimize. Total cost I wanted to minimize. Solar insolation I wanted to maximize. Now the surface area per volume, I'm just going to choose to ignore that right now. And also cost per insulation, I'm going to ignore that right now. Again, you can't choose them all, and if you do choose them, you're typically looking for things that trade off relative to each other. And cost per insulation, we can find out that measure actually sort of tracks with some of the other ones. So it's almost sort of more interesting to go through and just report that as a result, as opposed to try to optimize to that. If you try to optimize two things that are actually heading in the same direction, often you just drive to a single answer as opposed to sort of getting a trade-off. Okay, let's go ahead and just generate those and see what we come up with. So again, we'll get 10 different generations of these different points. What happens is you don't see all the points. What you're getting are the best-in-class cases. So the ones that sort of continue forward are the best ones. So you're not seeing a list of thousands of different generated alternatives. You're sort of seeing the best of the best. Okay, this one's taking a little bit longer to generate. So I'm just going to go ahead and let that run. How about this? Let's go through and just let that run. It'll kind of generate all those different cases. I think especially the solar analysis is what's taking a little bit longer there. You see the first generation starting to show up, but let's let that run in the background and we'll pick that up as part of our analysis of the results in the next step.